Hi there, this is Professor Eckhouse, and I'm going to talk today about multi-step linear equations. So again, it's always nice to know what you're about to learn, so you might want to pause and take a look at what it is we're going to be doing. Something to know is there's lots of videos embedded in the text, so don't forget there is a textbook. It's in your assignment right above the video typically. So there's lots of examples of every type of problem. All right, so we're going to start with solving linear equations, just straightforward linear equations. So something I like to do with people is to put a line down through the equal sign so that you remember that you've got two separate sides of this equation, that whatever you do to one side, you've got to do to the other side. But the first thing you want to do is combine like terms. So if you have like terms on the same side, you want to combine them. So I'm going to combine all of those. 2 plus 7 minus 1x is going to be 8x, and then we've got 5 and plus 8, and that is going to be plus 13. All right, so then we've got an equals 45. All right, so now keeping things on both sides of the equal sign, that's all that line is for, and if you don't need it, don't use it. All right, so now I'm going to subtract the 13 from both sides of the line or the equal sign, and the 13 is going to cancel out, and I'm going to get 8x equals 32. And now we want to divide both sides by 8, and we get x equals 4. All right, so now how could you make sure you got this right? Well, you would take your 4 and you would put it there, and there, and there, and check to see that when you add it all up on the left, you get 45. Okay, so what I recommend starting at this point is every time I bring up a new example, pause the video and do it yourself, and then see if you got it right. All right, so let's solve for x here. So again, I'm going to bring everything that's the same to one side, so similar terms. So I've got 5x and 3x, so I want to subtract 3x and bring it over to the left. And I choose the left not because it's the left, but because it will make my x term positive. I like to have positive x terms. It keeps me from making mistakes. So I've got 2x minus 6 equals 14. All right, then I'm going to add 6 to both sides. The 6's cancel out, and I get 2x equals 20. All right, now I'm going to divide both sides by 2. And I get x equals 10. As this course progresses, I am not going to show so many steps, but for now, if you need them, I'm showing them. All right, so that's just basic linear equations and solving for x. Now we're going to look at solving multi-step equations with absolute values. All right, so what does absolute value mean? So we're looking at the absolute value of x equals 9. So what could x have been? Now remember, when you take the absolute value of something, it always makes it positive. So that means that x can be 9, absolute value of 9 equals 9, and x could be negative 9 because the absolute value of negative 9 also equals 9. All right, so when we solve absolute value equations such as the one in example 3 down below, we're going to solve this by writing two equations, one equal to the positive and one equal to the negative. Okay, so this only happens when the absolute value of whatever it is alone on one side. Okay, it has to be isolated. Then you set it equal to both the positive and the negative, and I'll show you what I mean. So looking at this problem here, we've got the absolute value of 2x plus 6 equals 20. And what that means is that 2x plus 6 equals 20. And, so we've got two options here, 2x plus 6 equals negative 20. So think about why I just did that. Think about what we set up above, where the absolute value of x equals 9 means that x could be either the 9 or the negative 9. Whatever's inside the absolute values is set equal to the positive and negative of what's on the other side. Of course, it's got to be isolated, like I said, right up above, right up here. All right, so let's go ahead and solve for these. So I'm going to subtract 6 from both sides, and I get 2x equals 14, and divide by 2, and I get x equals 7. So there's one answer. And the other answer is to subtract 6 from this other one to x equals negative 26, divide by 2, and I get x equals negative 13. All right, we got two answers, and they're both true. So what I'd like to have people do and encourage you to do on a test always is to plug your numbers back in and see if they're true. But sometimes it also helps you to understand why. So at this point, I find that a lot of people don't really understand why there's two answers. So let's plug them back into the original. So we've got this original right here. So let's go plug it back into that. So we've got 2 times 7 plus 6 equals 20. And the other one, we've got 2 times negative 13 plus 6, absolute value equals 20. Okay, the absolute value is key here. We're plugging it back into the original that is highlighted up above. All right, so if you work out what's inside the parentheses here, you get 14 plus 6 equals 20, absolute value. And so the absolute value of 20 equals 20. Is that true? Yes, it is. The other one, we've got the absolute value of negative 26 plus 6 equals 20. So the absolute value of negative 20 equals 20. Is that true? Yes, it is. Yeah. Definition of absolute value is it makes everything positive. So they are both true. That's why there are two answers. All right, so let's continue on and do a couple more of these. So we've got to isolate, before we can set up, the first step every single time is to always isolate this absolute value before we can set it equal to the positive and the negative. So step one is always get the absolute value isolated. Okay, so we're going to isolate this, we need to add 5 to both sides. And we get 3 times the absolute value of 4w minus 1 equals 15. Now we need to divide both sides by the 3. Because it's multiplied, you can cancel it out. If it was added, you could not. So because it's multiplied, it's a factor, and we can cancel it out. So we get the absolute value of 4w minus 1, absolute value equals 5. All right, so now we can set up two different equations, right? So we're going to have 4w minus 1 equals 5, and 4w minus 1 equals negative 5. All right, so we're going to add 1 to both sides. That's just a little bit too big. Add 1 to both sides, and we get 4w equals 6, divide by 4, and you get w equals 6 over 4, which reduces to 3 halves. So that's one of our answers. The other one, we're going to add 1 to both sides. We get 4w equals negative 4, divide by 4, and we get w equals negative 1. Okay, so if you plug those back into the original equation, you will find that they both make it true. Okay, so be careful about when you choose to do this step here and here, setting it equal to the positive and the negative. You do that after you have isolated the absolute value. All right. So now we're going to solve equations with a distributive property. Why don't you pause the video and see how you do on this one? All right, so the first thing we want to do is, for problems like this, is to go ahead and distribute, and then we combine like terms. All right, so in this one, we get 8t minus 10 equals negative 6t minus 3. All right, so now we're going to have, if you want to, you can make a line. We're going to add 6t to both sides, and I get 14t minus 10 equals negative 3. Now I'm going to add 10 to both sides. And I'm going to get 14t equals 7. Now divide by 14. And I get t equals 7/14, which is 1/2. All right, continuing on. This one is, we're just doing one of each of these different kinds of problems, but we're going to use the distributive property to clear the fractions. So in order to clear fractions, you want to multiply everything by the least common denominator. The least common denominator here, the LCD, is 4. Okay, so I am going to multiply this one by 4 over 1, this one by 4. Same thing, it's just easier to see. This one by 4, and this one by 4 over 1. All right, so that's a little hard to see, but I'm trying to keep this quick, so we'll just continue on. So I've got 4 over 2x, and this one right here, 4 over 2x. And then we've got minus 12 equals 8 minus, now do you see that the 4's cancel here? We've got a 4 on top and a 4 on the bottom, so I've just got 3x. Now 4 over 2x is just 2x, right? 2x. All right, so let's rewrite this. 2x minus 12 equals 8 minus 3x. All right, so now let's just start working our way. So we've got everything in the same side that is a like term. So I'm going to say plus 3x plus 3x. Why did I choose to bring it over to the left? Well, it's because it makes it positive. 5x minus 12 equals 8. And now I'm going to add 12 to both sides. And I get 5x equals 20. Divide by 5. And I get x equals 4. If you plug that back in, you'll see it's true. And it is just a coincidence that the least common denominator was 4, and we got 4 as the answer. That doesn't always happen. It was just a coincidence in this problem. All right, so if you have a decimal and you want to clear the decimals, what would you do? So this time I'm going to write this out a little bit bigger. So I've got 3w plus, so I'm giving myself space actually. So a little spaced out is what I'm looking for. 6.5 plus 2.5. Now all of these have a tenths, right? That's the decimal that's the farthest to the right is tenths. So what we want to do is multiply everything by a 10. Okay, so if you multiply everything by 10, it will get rid of the decimals. Easiest way to do this. All right, so I've got 30w plus 10 times 10.5 is 105. It moves the decimal place over to the right one. 10 times 6.5, move the decimal place to the right one, I get 65. Again, decimal place to the right one, I get 25, and the w is there. All right, so now I want to get my w's, I think, to the left so that I have positive w's. And I get 5w plus 105 equals 65. And now I'm going to subtract 105 from both sides. And I get 5w equals negative 40. And now I'm going to divide both sides by 5. And I get w equals negative 8. All right, a few more examples. Again, you can skip all my work to the end if you want to move faster through these videos. So try it yourself and then skip through to the end. All right, now these are interesting. These are classifying solutions to linear equations. Now, sometimes we have just one solution, but sometimes we have no solution. In other words, it does not exist. In other situations, we might have infinitely many solutions, which we also call all real numbers. There's a symbol for that. We use kind of a fancy R like that, double barred R. All right, so what you want to do with these is you want to simplify. So simplify this and see what happens. So I'm going to combine and bring things together, and I get, when I bring this together, and I'm going to skip some steps here, but no, I'm not. I'm just going to do this. 2x, and then I've got plus 4 on the left side, and then I'm going to combine the two x terms, and I get 2x plus 5. All right, that's weird. So think about it from there, but I'm going to continue just so you can see what happens. So if I subtract 2x from both sides, it goes away on both sides. And I end up with 4 equals 5. And that, in this universe, is never true. So there are no solutions. And you can also just look at it in this step right here and see that there's no way that's ever going to be true. In other words, the solution does not exist. All right, give this one a try. All right, I'm going to combine like terms on the left, and I get x plus 3 equals 3 plus x, which of course is the same exact thing. So any number I put in for x will make this true. I could put in a 1, a 5, a 10, a 20, a million. It'll still be true. So the solution to this is infinite solutions, right? There are infinite solutions. And the way we say this is all real numbers make it true. Okay, which is also not simple. All right, one more of these. Give it a try. All right, if I distribute this, I get 12x minus 6 equals 12x minus 6, and you'll see that all real numbers make this true. All right, so last topic, absolute value equations with no solutions. So what can the absolute value of any expression not be equal to? So the absolute value of anything cannot be equal to a negative number. It's the easiest way to say it, right? Can't be equal to a negative number, ever. So let's look at some of these problems down here. You can probably anticipate what's coming here. I'm going to subtract 10 from both sides, and I get the absolute value of 3x minus 6 is equal to negative 8. Well, an absolute value cannot equal a negative. This negative right here makes this impossible. So the answer does not exist. There is no solution. No solution to this. Okay, one more. You try this one. All right, I'm going to divide both sides by negative 2. Let's make that orange. By negative 2. The negative 2's cancel, and I get absolute value of 4x plus 7 equals negative 10. Similar to the last one, the process was just a little different to get there. But again, we can't have an absolute value equal to a negative number. Right? When I take the absolute value of something, it will always be positive. So this is impossible. And there is no solution. No solution. In other words, it does not exist. All right, that was my last example. Thanks for watching.